Hola clase! Today we are going to be talking about mathematics. Now we are going to be covering 3 topics with 3 problems. Solving triangles, coterminal angles, and combination versus permutation. Let's get right into it. To start off, we're going to be looking at solving triangles. Now, to do so, we're going to start with the law of sines. First, the law of sines says that sine A over side A equals sine B over side B equals sine C over side C. Now this formula only works with angle angle side, side angle, and side side angle. So for our example, we have triangle ABC. And our problem states that angle A here is 37 degrees, B is 14, and A is 21. Now to set this up, we're going to be using this proportion. Sine 37 over 21 equals sine B over 14. When we plug that in, we get sine B equals 14 sine 37 over 21. So, through our calculations, 14 sine 37 over 21 equals 0.40121. Then we use sine inverse to find the measure of angle B, which ends up being 23.65 degrees. Then, to find the measure of angle C, we use 180 minus 37 plus 23.65 in parentheses equals 119.35 degrees, which in turn is an obtuse triangle. Then, we use length C over sine 119.35 equals 21 over sine 37. Therefore, C equals 30.42, and our triangle is solved. Now that we have talked about law of sines, we can add law of cosines to our arsenal of mathematic tools. So, to begin, a squared equals b squared plus c squared minus 2bc times cosine A. These three, a squared, b squared, and c squared, are all interchangeable in the formula. Now this formula works for side, 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 and side, angle, side, but in this case, we will be doing a side, side, side example. A equals 10, b equals 13, and c equals 18. Now, when we plug our numbers into the formula, we get an equation that looks like this. 10 squared equals 13 squared plus 18 squared minus 2 times 13 times 18 times cosine A, which, after a bunch of calculations, substitutes down to 0.8397 equals cosine A, which when we use our inverse function, as we did in law of sines, equals 32.89 degrees. Now that we have this angle, we can use law of sines to solve the rest of the triangle as shown in this work. And through law of sines, we determine that angle B equals 44.91 degrees and angle C equals 102.2 degrees through our 2 sets of calculations. Okay class, for our next topic we are going to be talking about coterminal angles. Now, according to Larson Algebra 2, coterminal angles are 2 angles whose terminal sides coincide. So let's get into some examples. Okay class, to start off we have to learn how to graph a basic angle. In this case, we'll be graphing 210 degrees. So, we start with our graph on the x-axis and go 210 degrees right to this angle. Now, with our other Sharpie, we can determine that 180 degrees to here plus 30 goes to 210 degrees. So this is a 210 degree angle on the graph. So, now we can talk about coterminal angles. If we start with a 480 degree angle, we must subtract 360 degrees. So, 480 minus 360 equals 120 degrees. So, if we look at this, 480 and 120 are coterminal because their coterminal sides coincide. Now, on the graph it looks like this. If the angle is 480 degrees, we would go around 1 revolution this way, plus 120 more to get here. But, instead of going all the way around, we can simply go from 0 degrees to 120, because 480 and 120 are coterminal. But if we do go all the way around, we go 1 full revolution to here, plus 120, to get to that point, which would be a 480-degree angle. Now our next topic is what happens if the angle is less than 0 degrees. In this case, we start with negative 100. So, if we add 360 to negative 100, we get 260 degrees. So, if we go to 180 plus 80 degrees more, that gets us right to 260. But, if we go the negative route, it goes from 0 straight there to be a negative 100 degree angle. But because negative 100 and 260 are coterminal, we can also go positive around this way, and that gets us 260 degrees. Okay, so for our last topic, we're going to be talking about combinations versus permutations. So, one main difference is that in combinations, the order does not matter, but in permutations, the order does matter. Knowing this, let's get into some examples. To start, we're going to be talking about permutations. So, for a practice problem, use a permutation to determine the number of ways to introduce the 5 starting members of the Los Angeles Lakers. To do this, we're going to be using our permutation formula, NPR equals n factorial over n minus r factorial. So, for this example, n is the total amount of players we have, and r is how many we want. But in this case, n equals 5 and r equals 5. Therefore, 5 factorial over 0 factorial. But because 0 factorial equals 1, the answer is simply 5 factorial. And when we do the math, 5p5 equals 5 factorial. So, another way to explain this is by using these 5 lines. To pick the first player, we have 5 options. Then, to pick the next one, we have 4. Then 3, then 2, then 1. And when we multiply these all together, we get 120 ways. So, 5p5 is the same as 5 factorial. Now we can talk about combinations. So, how many different combinations of 3 flavors for your 3 scoops of ice cream at Baskin-Robbins? So, we're going to do this using our formula. NCR equals n factorial over n minus r factorial times r factorial. So when we break this down, there are 31 total flavors at Baskin-Robbins, and we are choosing 3. And in a combination, order does not matter. So, when we do 31C3, we get 4,495 combinations. Thank you for watching, class. I hope you learned more about math. Don't forget to estudiar mucho para tu final.